This is an introduction to deep movement, a neural style transfer web application built by the team The New Normal. Deep movement combines art and science by using neural style transfer, transfer learning, feature extraction, and distance calculation to give users insight into who they would be and what art movement they would belong to if in fact they were an artist. What if you're already an artist? Then maybe you want to be an astronomer. The included art movements span from the Renaissance all the way to pop art, Art Deco, and even astronomical art, as shown in this example from our front-end user interface. Users will be able to upload their own content and style images, and Deep Movement will generate a new output by transferring the style onto the original content, and will then find the most similar work of art from our artist database of thousands of paintings across hundreds of years and return that image and information about its associated art movement. Each layer of a convolutional neural network consists of filters which extract different features and can be referred to as feature maps. If a CNN is trained for object recognition, the feature maps become representations about objects or the content of the image, rather than the actual pixel information. Therefore, features from deeper layers are known as content representations. The lower layers tend to capture very basic pixel level information of the input image, and the deeper layers collect higher level features of the image, such as complex textures and object classes. In order to generate an image similar to the content image, it's important to select a convolutional layer in the middle or higher of the pre-trained network representing content to a high degree. Our models were originally trained on data obtained from wiki art found on the Kaggle Painter by Numbers competition with 36 gigabytes and 11 gigabytes of train and test data with thousands of images. We also added astronomical photos captured by Google Images. The components used in this project are shown here. The Docker environment was used to separate the application from the infrastructure, Flask for web application framework and deployment, Bash script for pipeline automation, Google Cloud for compute engine and bucket storage, and VGGNet, MobileNet, and Inception for transfer learning. We use TF Hub for easy access to pre-trained models, Magenta pre-trained models for style transfer. We also used Google Colab and Drive for interactive development and collaboration. And of course, we used Python and TensorFlow for coding and deep learning. Our process is shown here. We used the Magenta architecture from TF Hub, trained on the Painter by Number data. Then we performed transfer learning using WikiArt and astronomy data for the style piece and the DOG subset of ImageNet for the content piece. We use Inception v3 mode for style and VGG16 for content. Then we perform transfer learning to create a stylized image. At that point, we used subrotation 100 for feature extraction, then calculate the distance between images in our artist database to obtain the painting most like the stylized image. This is a snapshot of our code for further perusal. Here you can see how we turn this application into a product with input data, a transfer model, and user access to the front end with actions controlled by a working backend. We found that Magenta by itself did not create quality images for astronomy styles, but performance was improved after adding these images to our training dataset. In addition, our distance model also performed well with the astronomical images. In the future, we would like to improve front-end performance by model pruning and other optimization techniques. Our hope is that with deep movement, the user not only learns about the concept and capabilities of neural style transfer, but also learns a little about art itself and the various movements through time, and possibly even finds a new interest in astronomy. We feel that the intersection of art and science is truly unconfined by the walls of logic, and neural networks will propel the creation of art into the future by redefining computer vision limited only by the imagination.